This lesson is lesson 86 for Algebra 1. So Algebra 1, lesson 86, due Friday, 3/27. So Algebra 1, lesson 86, due Friday, 3/27. Okay, this is about midpoint, calculating midpoint and length of a segment or distance between 2 points. So we're going to talk about midpoint first. Midpoint is very, very easy. You're just going to average the x's and you're going to average the y's. That's all you're going to do. So you could be given 2 points like 2, -2, and 4, -3. And you want to find the midpoint. So I want to find the midpoint. So that means I'm going to take my x's, 2 and 4. So 2 plus 4 divided by 2. 2 plus 4 is 6, divided by 2 is 3. So the x-coordinate of your midpoint is 3. Okay? Then for your y's, -2 plus -3, and you're always adding. You're always adding. It's averaging. Averaging is adding and dividing. So make sure you add. And I'm dividing by 2. I'm always dividing by 2 because I'm averaging 2 numbers. That means I'm dividing by 2. That's -5/2. And just leave it as -5/2. Don't give decimals. Just leave it as improper fractions. Don't give mixed numbers. Leave whole numbers and improper fractions. That's what I want to see on that. I guess I could show you a few more. Finding the midpoint, like I said, it's really, really easy. So 7, 10, and 5, -4. So if I want the midpoint, I just average the x's. So 7 plus 5 divided by 2. So that's 12 divided by 2. So that's 6. So the x-coordinate is 6. And then 10 plus -4 divided by 2. So that'd be 6 divided by 2, which is 3. So your midpoint is 6, 3. You just add the x's and divide by 2 and add the y's and divide by 2. That's all you do on midpoint. Okay. Now we're going to do distance. Distance between 2 points. Okay. Distance between 2 points. So this has a formula. And so whenever you do this, just like with Pythagorean theorem, you're going to write the formula down because you need to memorize the formula because you're going to need it from now on. You're going to see distance formula next year in geometry, the next year in Algebra 2. You're going to see it in pre-calculus. You're going to see it in your college classes. You're going to have to know the formula for the distance between 2 points. So to find the distance between 2 points, you've got to be given 2 points, which I'll just use those 2 that I just had. 2, -3 and 4, 2, -2 and 4, -3, and we want the distance between the 2 points, so we just plug in. So that means I take my x's, 2 and 4, so I draw this, my x's 2 and 4, so 2 minus 4 all squared, because that's the formula. You subtract your x's, you subtract your y's, you square them, add them, and then you take the square root of it. Okay, so it's subtraction in there. So be careful when you've got negatives. So my x's were 2 minus 4. My y's are -2 minus -3, all squared. So then we do this. -2 squared plus, this is -2 plus 3. -2 plus 3, which is 1 squared. So then -2 squared is +4 because you're squaring the negative. You should never have a negative number underneath here taking the distance of it. Never, ever, ever. Because you're squaring, and squaring always brings positives. And then 1 squared, so it would be 5, so it would be the square root of 5. Sometimes you're asked for simplified radical form. Which this would be simplified radical form. Sometimes you're asked for a decimal approximation. So to find the decimal, if you want the decimal approximation, again, I know this calculator isn't exactly like yours, but it still works the same because it's a TI. you're going to hit your second key, and your calculator has a second key. You're going to go down to your x squared key and hit x squared, so it brings the radical up there. You're going to put the 5 in, and you're going to hit enter, and you're going to round it to whatever you're asked to round to. So let's say if we did the nearest hundredth, it would be 2.24. That'd be rounded to the nearest hundredth. So just read carefully. If you're asked for simplified radical form, leave it in a radical form. Simplify it if you need to. I'll show you a couple of those. And then if you're asked for a decimal approximation, do the decimal approximation using your calculator. Using calculator just like I showed you. Okay? So let's try another one. Try another one of distance between 2 points. So distance between 2 points, points 3, -2 and 6, 4. So I'm going to find the distance, so I'm going to write the distance formula, which is what I want y'all to do. And then I put my x's in, 3 minus 6 all squared. I put my y's in, -2 minus 4 all squared. So again, I take my x's, which are 3 and 6. Those are the first ones, 3 minus 6. I take my y's, -2 and 4, so -2 minus 4, because the formula is subtraction. Then 3 minus -6 is -3. -2 minus 4 is -6. -3 squared is +9, because a negative squared always makes a positive. -6 squared is 36. That would be the square root of 45. So if we wanted it in simplified radical form, if we want it in radical form, we can't leave it here because it simplifies. Because 45 is 9 times 5, so 3 times 3 times 5. So it'd be 3 square roots of 5. Because you take the pair. Then if we wanted a decimal approximation, we just, on our calculator, second x squared, type in the 45, hit enter, round it to 6.71. Let's, distance between 2 points. Another one. Let's just try that one and see what happens. Okay, so I want to find the distance between these 2 points, 7, 10, and 5, -4. I want to find the distance, so I write the distance formula, x2 minus x1 all squared, plus y2 minus y1 all squared. So there's my distance formula. Plug in my numbers. My x's are 7 and 5. My y's are 10 minus -4. So again, be careful with those signs because it is subtraction. So 7 minus 5, 10 minus -4. So this becomes 2 squared. This becomes 14 squared. So this would be a 4. This would be a 196. Let me check my math right quick. So that's 200. So I need the square root of 200. So again, if I want a decimal approximation, second x squared 200, it'd be about 14.14. Then if I want radical form, they call it simplified radical form or radical form, you take the 200, you divide by 2, you get 100. Now we saw this on the last one when we were doing Pythagorean theorem. So if you get here and you're like, wait a minute, 100 is 10 by 10, or 10 times 10. So it would be 10 square roots of 2. If you get there and you don't recognize that, then keep going. You divide by 2, it's 100. Divide by 2 again is 50. Divide by 2 again is 25. And then 5 and 5. So you take one of the 2's. Two of the 2's become 1, 2. 2 of the 5's become 1, 5. 2 times 5 is 10, and then that's left over. So 10 square roots of 2 right there. Okay, and that's really about it. Let me go ahead and make the assignment for you. And then there's something else I want to talk about. Let's see. Okay, so on 86, that's due Friday, you're going to do the warm-up, of course, which is on page 563. You're going to do the practice, just B, D, and E. Those are the only practice ones I want you to do. And then you're going to do 8, 22, 24, 26, and 30. That's what you're going to do. Those are what you're going to do. You're going to do the warm-up. You're going to do practice B, D, and E. You're going to do 8, 22, 24, 26, and 30. Now, I do want to tell you on E, I'm just going to tell you which points to use on that, on E, and it's distance formula. So on E, it says use a coordinate plane. You don't have to use a coordinate plane. A quarterback is on the 20-yard line at 20:35, so that's that's where the quarterback is. That's your quarterback. And he throws a pass to his receiver who is on the opponent's 58-yard line, which is at 58. Okay, so you're just going to use these 2 points right here in the distance formula. X2 minus X1 all squared plus Y2 minus Y1 all squared. Okay, so you're just going to use that in the distance formula, find that distance, and just calculate it. No simplified radical form on here, no radical form. Only round it to the nearest yard. So round to nearest yard. Now the book asks for simplified radical form. I don't want it. So this is what I want. I want you to round it to the nearest yard. Don't do the simplified radical form, okay? Just round to the nearest yard on that one. The rest of them are pretty straightforward. 22 is Pythagorean theorem. Shouldn't have any problem with that. 24 is Pythagorean theorem. 26 is Pythagorean theorem. On 30, let me talk about 30 just for a second. It was actually 30. 30 is kind of like the practice one. You've got a baseball diamond. It's a square 90 feet long. Use a coordinate grid. Don't worry about it. Because they give you the coordinates. They've got home plate at 0, 0. They've got first at 90, 0. They've got second at 90, 90. And they've got third at 0, 90. So an outfielder at 5,300. So 5,300, there's your outfielder. That's 1 point that you're going to use. And he throws to the third baseman. So he throws to this. So you don't need these. These are the 2 that you need to use in distance formula. You use the 0, 90, and you use the 5,300 in the distance formula. The square root of x2 minus x1 all squared plus y2 minus y1 all squared. Okay, again, let's do Friday. There you go.